Hi guys. Okay, so today the first thing we're going to talk about is simplifying rational expressions. So in order to simplify a rational expression, which is really just a fraction, you factor the numerator and the denominator, and then you divide out any common factors. Okay, so a rational expression or a fraction is in simplest form if the numerator and the denominator have no factors in common other than the number 1. All right, so let's try one. Let's see what we're talking about here. So we have the fraction 2s squared plus 8s over 3s plus 12. We are going to first factor out the greatest common factor in both the numerator and the denominator. So in the top, we have 2s squared plus 8s. What do they have in common? What goes into 2 and 8? That would be 2. Do these terms have a letter in common? Yes, they both have an s. So now we have to remember, if you bring it out, you have to pull it down. This time we have to pull it across. And we open up one parenthesis for the answer for the division. 2s squared divided by 2s. The 2's divide to 1, and s squared divided by s is just s, because those exponents, 2 minus 1, give us an exponent of 1. Now 8s divided by 2s. 8 divided by 2 is 4, and the s divided by s is just 1. They cancel out. We've got the top. Now let's do the bottom. What do they have in common? What number goes into 3 and 12? That would be 3. Do they have a letter in common? No, they do not. So we write the 3. We open up a set of parentheses. Now, 3s divided by 3. The 3's divide to 1. We get s. Plus 12 divided by 3 is 4. Okay, so now we have it factored. The next step is to divide out the common factor. Notice on the top we have an s plus 4, and on the bottom we have an s plus 4. They are an exact match. Because it's an exact match in the parentheses, we can divide them out to 1. And the last step is to simplify. We have a 2s in the top, and we have a 3 in the bottom. And notice there's no number that goes into 2 and 3 other than 1. And only the top has an s, so they have nothing in common. Okay, let's try example 2. So example 2. First thing we're going to do is factor out the greatest common factor in the numerator. So if we look at the top, what do 3x and 12 have in common? What goes into 3 and 12? That's a 3. They have no letter in common, so it's just the 3. Now 3x divided by 3 is x, and 12 divided by 3 is 4. So we factored the top. Now we need to factor the denominator. Now the denominator does not have a greatest common factor. The only number that goes into 1, -1, and -20 is 1. There is no common letter because the 20 doesn't have an x in it. It's not different to 2 squares because there's 3 terms, so it's a trinomial factoring that we're going to do. So we need to find numbers that add to that middle -1 and multiply to -20. Now if they're multiplying to a -20, the signs have to be different so that we get a -20. And since the signs are different and they have to add to this -1, we need the bigger number to be negative, which means the smaller number is positive. So we need a small positive and a big negative. Now let's think about our factors and their sum. Okay, so 1 goes into 20 times, and we keep the first one positive and the second one negative. Add them up, we get -19. Does 2 go into 20? It sure does. It goes in 10 times. And again, the small one is positive, the big one is negative, and they're going to add to -8. Still not what I wanted. Does 3 go into 20? No. Does 4 go into 20? Yes, it goes in 5 times. I keep the small one positive, the big one negative, and if I add them, I'm going to get -1. That is what I want them to add to, so now I have my magic numbers. Now remember, when I'm setting up my 2 parentheses for this trinomial factoring, I have an x squared up front, and notice my middle term is an x. That means I need an x and an x in the beginning of each parentheses, and then my magic numbers, +4, -5. Okay, now we can divide out any exact matches. I have an x plus 4 in the top and an x plus 4 in the bottom. Those will divide out to 1. Now all I have to do is simplify. That 3 times 1 in the top is 3, and in the bottom all I have is x minus 5. And we're done with this one. Let's try example 3. So the first thing we need to do is factor both the numerator and the denominator. Now notice both of these are trinomials, okay? And in the top, we're going to have 2 parentheses. And notice since we have a c squared and the middle term is c, we're going to need a c in the beginning of each parentheses. And I am factoring. My 2 numbers have to multiply to a -6. If they're multiplying to a -6, the signs must be different. And the bigger one has to be negative since they're adding to a -1c. So I need a small positive and a big negative. Now let's look for our factors and their sum. All right, 1 goes into 6 times. We keep the 1 positive and the 6 negative. We add them and get -5. Now, how many times does 2 go into 6? 3. The 2 is positive, the 3 is negative, and when I add them, I get -1. There's my magic pair. Okay, so we're going to put our magic numbers, +2 and -3 in there, all over. Now in the bottom, we're ready to factor. We have another trinomial, so 2 parentheses. We have a c squared again with a c in the middle, so we need a c and a c in the beginning of each parentheses. And I am factoring. My 2 numbers have to multiply to a +6, which means their signs are the same. And since they're adding to a +5, they're both going to be positive. Now our factors, since we're multiplying to 6 again, they're going to be the same numbers we just had, 1 and 6 and 2 and 3. But this time, all my factors are positive. And 1 plus 6 adds to 7. Not what I wanted. 2 plus 3 adds to 5. That is the pair I want. So I'm going to put a +2 and a +3. Now we're ready to divide. Now remember, we can only divide out exact matches. A c plus 2 with a c plus 2. We cannot divide out a c minus 3 and a c plus 3. Now we simplify. So the only thing left in the top is c minus 3, and the only thing left in the bottom is c plus 3. Now notice I kept my parentheses. I did that for a reason, because I have a lot of students who, when they see this, they cross out the c's. You cannot do that. Some will say, oh, I have a c minus 3 and a c plus 3. I can cross out the 3's. No, you can't. It has to be an exact match. C minus 3 is not the same as c plus 3. I cannot simplify that any further. You're done. Okay? Very, very important. Example 4. Guess what we're going to do? It's what we always do first. We factor first. So we're going to factor the numerator and the denominator. Okay, so for the top, that does not have a greatest common factor. It's also not a trinomial because it's 2 parts with subtraction in between. So it's the difference of 2 squares. The square root of y squared is y, and the square root of 64 is 8. So that means we're going to have y plus 8 and y minus 8 all over. Now, on the bottom, we do have a trinomial. There is no greatest common factor, so we're going to set up 2 parentheses. We have a y squared in the front with a y in the middle. So we're going to have y and y. I am factoring. So if they multiply to a positive 64, that means their signs have to be the same. And if they're adding to negative 16, it means they're both negative. So now let's look at their factors and their sum. Let's see. 1 goes into 64 times, and we're going to make them both negative, and that adds to negative 65. Not what we wanted. 2 goes into 64 32 times, and we're going to make them both negative. That's negative 34. Again, not what I wanted. 3 does not go into 64, but 4 goes into 64 16 times. Make them both negative, and that adds to negative 20. Still not what I want. 5 does not go into 64 evenly. 6 does not go into 64 evenly. 7 does not go into 64 evenly, but 8 goes into 64 8 times, and we make them both negative. So negative 8 plus negative 8 is negative 16. There's my magic pair. So we're going to put a minus 8 and a minus 8. Okay, now we're ready to divide. Do we have any exact matches? We do. We have a y minus 8 and a y minus 8. But those are the only exact matches we have, because in the top, keep it in parentheses, y plus 8. And in the bottom, y minus 8. Notice what's in the parentheses on the top is not an exact match for what's in the bottom. So that's it. We're done with that one. Okay, now the next thing I want to talk about are undefined fractions or excluded values. You all know that you cannot divide by 0. It's not possible. It blows up the problem. And remember, a fraction is a representation of division. It's top divided by bottom. So if the bottom of the fraction is 0, it doesn't work. The fraction doesn't work. The fraction is undefined. So a fraction is undefined when the denominator is 0. And whatever values of x make that denominator 0 are excluded from the domain of the function. Those values are not allowed to be used. They're called excluded values. So to find excluded values, or when the fraction is undefined, factor the denominator if necessary, and we set our denominator equal to 0 and solve. Notice, all I talked about was the denominator. I care nothing about what's in the top. We get to ignore it completely. Okay, so if I ask you to find the excluded value for this expression, x squared plus 4x plus 3 over 2x minus 1, the excluded value is when the denominator, 2x minus 1, equals 0. I only care about the bottom. I have a little equation to solve now. The opposite of subtracting 1 is adding 1. Now I have 2x equals 1. So 2 times x, the opposite is divide by 2, and I get x equals 1/2. That is my excluded value. That fraction will be undefined when x is 1/2. Let's try another one. This time I'm asking for which value or values of x is that fraction 9 over 8x minus 16 undefined. So again, if I'm asking when the fraction is undefined, I take the denominator only and set it equal to 0. Now we're going to solve. I have minus 16, so the opposite is add 16. So I have 8x equals positive 16. Now I have 8 times x, So the opposite of multiplying by 8 is dividing by 8. So x is 2. So my fraction is undefined when x is 2. My excluded value is x equals 2. Notice, I asked in part A to find the excluded value. In part B, I asked when the fraction is undefined. And now in part C, I'm asking when does the expression have no meaning? They are 3 different ways to ask the same exact thing. Each one of those, find the excluded values, find when the fraction is undefined, or when does the expression have no meaning. You take whatever the denominator is, set it equal to 0, and solve for x. Now this time we have an x squared. That means we're going to need to factor. Now there is no greatest common factor, and we only have 2 terms with subtraction, so it's the difference of 2 squares. The square root of x squared is x, and the square root of 1 is 1, so I factor this x plus 1 times x minus 1, and that's equal to 0. Now if I have 2 things multiplying to 0, either the first one is 0 or the second one is 0. Now I have too many equations. X plus 1 equals 0, so the opposite of adding 1 is subtracting 1, and I get x equals negative 1. On the other side, x minus 1 equals 0. The opposite of subtracting 1 is adding 1. And I get x equals 1. So I have 2 values of x when the fraction has no meaning, or 2 values of x that have been excluded, and 2 values of x for which the fraction is undefined. Okay, guys, we're going to stop here. Have a great day.